Hello my dear students, I welcome you to NEET World. So in this session we will be discussing CUET UG 2022 chemistry question paper. Okay, so this session will be very benefited for those students who are seriously preparing for CUET UG 2025 and 2022 examinations. Okay, so in this session we will be covering chemistry questions. Okay, so let's start our session here. The first question given in this question paper is, among the following statements choose the correct statement. Okay, so they have mentioned few statements and we need to pick the correct one out of it. Okay, so this is something like a multi-selective question. Okay, like see, first option you can check once. An ionic solid, in an ionic solid, ions are the constituent particles. Yes, now for example if we say sodium chloride salt, okay, it's a crystal, right? So if we take the solid form of that like NaCl, so what it is made up of? It is made up of Na plus and Cl minus ions. Yes, first statement is correct. Okay, so I am taking the first one. Okay, next, ionic solids are soft. So now tell me, what about this? Ionic solids are soft or hot? Okay, so these are ionic solids are rigid and hot, right? Okay, then next, ionic solids are electrical insulators in the solid state. Yes, so ionic solids, like particles will be very closely packed and there is no mobility of particles in their solid state. Therefore these ionic substances are considered to be what? Hard in nature. What is that? I mean insulators, hard and insulators. Okay, that is also correct. Okay, ionic solids conduct electricity in molten state. Yes, so sodium chloride in solid state will be act as a insulator, whereas if we make the molten form of that, so it will be having ions. Now these free ions having free mobility, therefore they will be responsible for the conduction. Okay, so they can be a good conductors in molten state. Okay, then next, ionic solids have low melting and boiling point. No, ionic solids have high melting points, right? Okay, so which means ACD. So ACD we have option 1. Okay, so that is our correct answer for this particular question. I hope it is clear. So how we are choosing the things, right? So first option you can tick here, right? Let's move further. The second question, the atoms of element B forms HCP lattice and those of element A occupies 2/3 of tetrahedral voids. What is the formula of the compound formed by element A and B? So this is also easy question from solid state. See, atom of an element B forming HCP lattice. So total number of B atoms, now how many are there? So for forming this HCP we required 4 atoms, right? So I can say B4, I am writing B4, fine. Now we know number of tetrahedral voids and octahedral voids, how many are there? 4 tetrahedral voids and 8 octahedral voids. Sorry, 4 octahedral voids and 8 tetrahedral voids. How many tetrahedral voids? 8 tetrahedral voids are there. Okay, so I think you know about the structure and all, so I am directly explaining it. So how many tetrahedral voids are there? 8 are there. Okay, so in that 8 tetrahedral voids, 2/3 is occupied. So 2/3 of, I am taking 8. Okay, so now how can I write this? A16/3 B4. Okay, simple, we can write like this. So now I am taking A16 B 4 3s are 12, like this. Okay, now take the simplest ratio as per the given options. So we can write 4 3s are 4 4s. Okay, so A4 B B3. So A4 B3 we have option A4 B3, option number 2 is correct for this particular question. Hope it is also clear now. Okay, let's move further. Here, consider the 1 molar aqueous solution of the following compounds. Arrange them in the increasing order of their elevation in boiling point. Okay, so this is from colligative properties solutions chapter. Okay, so how can we do this? Let's start. So delta TB, elevation in boiling point we are discussing now. So this will be equals to I kBm. So what is this kb here? It is a constant. So we can say molar elevation constant. Okay, and M means concentration in terms of molality. Okay, so since the molarity concentration is given and that is constant for all, that is same for all the four given options, all the 5 given options, concentration is same. So this is same, and Kb also constant, that value of Kb depends only on the solvent. Okay, so Kb also same because everything in aqueous solution means solvent is water, so Kb value for water is same in all the cases. Now elevation is boiling point will depends only upon what? I value, that is what? Van 't Hoff factor I. Okay, so now higher the value of I, greater is its elevation in boiling point. So how can we say the I value for this given compounds? Now look here, so this is an electrolyte na, Al2SO4 tries. Okay, so this will be giving 2 Al plus 3 ions and 3 sulfate ions like this. So total number of ions are how many? 5 ions are there. Okay, so in option 5 ions are there. So in option D, how many are there? One is Al plus 3 ion and 3 Cl minus ions. So total ions are 4 here. Okay, here MgCl2 means this is 3 ions, NaCl 2 ions, and this C6H12O6 glucose, it's a non-electrolyte, 1 ion. So number of ions produced, like how many particles are there? So that is what we need to count here. So particles are how many? 3 aluminium plus ions particles are 2 aluminium ions and 3 sulfate ions. That is means total 5 particles. More the number of particles, more is its elevation in boiling point. So how can we write? So I value is more for this one E, so it is having more elevation in boiling point. The next D, so just arrange based on these values, E, D, C, B, A, that's it. So do we have any option like this? E, D, C, B, E, A. So option number C is correct here. Okay, I hope it is clear, there is no confusion in this discussion, right? So let's move forward. Calculate the molarity of a solution containing 5 grams of NaOH in 450 ml of solution. So how can we find this? Molarity equals to number of moles solute by volume of solution in liters. Okay, now number of moles I can write as given weight by molecular weight, gram molecular weight of solute into 1000 by volume in ml, we can write like this. Now place the given values, molarity equals to what is the weight they given? 5 grams. Okay, so what is the gram molecular weight of NaOH? So for sodium it is 23, for oxygen 16, for hydrogen 1. So that will becomes how much? 40. Okay, I am writing 40. Okay, into 1000 by how much we have here? 450. That's it. Volume is 450 ml. Okay, so now remove this 0, these 2 zeros. Done. Then next we are remaining with 5. Okay, so here I can write gram per mole, right? Okay, this gram cancel, so that we can get mole per liter now. So this goes up. Okay, so now what we are remaining with? So 5 9 ja 45. So next 2 ja 5. So we are remaining with 5 by 18 we have. Okay, so now this I can write 0. So 50. So this will be 2 times. Okay, so 2 times means 36, remaining 14. Okay, so again placing 0, so that we will get around 2.78. So this is what the molarity we are getting. So here we have this one, this second option we have 0.278. 0.278 is the exact answer for this. I hope it is clear, there is no confusion now. So this is the remaining value we have. So that is the molarity of this particular solution, which is option number B. Okay, hope it is clear, there is no confusion. Let's move further. Fifth question here, among the following statements related to ionic conductance, choose the correct statement. Okay, so ionic conductance, yes, so depending on based on the options we will go. So ionic conductance depends on the nature of electrolyte, yes. So whether it is strong electrolyte or weak electrolyte, so it is depends upon ionic conductance, depends upon the nature of electrolyte. Okay, ionic conductance is due to movement of electrons. No, the name itself saying ionic conductance, it is conductance due to presence of ions. Okay, so that is not due to electrons. So in metals, normal metals will be there now, like iron and all. So in those metallic substances, the conductance is due to mobile electrons, okay, but in ionic conductance it is due to presence of ions, not due to electrons. So you can remove B. So here option A, so what they are asking, correct, choose the correct one. So here B is mentioned, so remove that. Here also B is mentioned, remove that. Here also B is mentioned, remove that. So we have only option D, in which option this fourth option only we are not having this B statement. So therefore we can directly go with that option as a correct one. Hope it is clear how I am solving. Let us look for the other statements also. Ionic conductance is also called as electronic conductance. No. So metallic conductance is there now. In metals, electronic conductance. In metals, the conductance is due to electrons. So therefore we can say them as electronic conductance. Okay. So this statement valid for metals but not for the ionic conductance. Okay. So I am removing this C option also. Okay. So C is there in first three, so I am removing, so that we got a clear that only last option is correct out of the given statements. Okay. I mean in this option, this is the only correct option I can choose. Okay. You can also verify the other options also. Okay. Ionic conductance, yes, temperature dependent. Next, ionic conductance also depends on nature of electrolyte. Okay, fine, that is also. So let's move further. Option D is correct here. A, D, E is correct here. Okay. Now like limiting molar conductance for different electrolytes are given, like NaCl, HCl and NaOAc is given this much values, and calculate for this electrolyte they are asking. This is what Kohlrausch law. Okay. So what is the use of Kohlrausch law? So we can find limiting molar conductance of weak electrolytes using a limiting molar conductances of strong electrolytes. Okay. So that is what the application of Kohlrausch law. So I just want to find limiting molar conductance of this acid, acetic acid it is actually. Okay. For this, see what are the cation we have in the acetic acid. If I write like this as acetic acid, so what you will be mentioning like this. So this part here it is mentioned as ACO. Okay. So this part is given as ACO and hydrogen as H, that's it. Okay. Now this I can write delta naught of ACO minus, okay, plus delta naught of H plus. Okay. So this is what we required, but we know acetic acid is a weak electrolyte, so we cannot get this value directly from acetic acid. So for that purpose we have strong electrolytes which are giving this H plus ion and which is giving this OAC ACO minus ion from here, sodium acetate ion. So that I can use the value of this in place of here and I can use the value of this in place of here. So let us use these terms. Okay. So instead of writing this ACO like this, so sodium acetate I am writing. Instead of writing simple acetate I am writing sodium acetate here, and instead of writing H plus I am writing here HCl. Okay. I hope it is clear up to here. Then next minus, so in this we required only H like H plus ion conductance and acetate ion conductance, but here we have sodium which is extra part, here we have chloride which is extra part, so that I am removing them as delta naught of NaCl. Okay, this is a basic thing, right? So I hope everyone knows about this. How can we do now? So sodium acetate, what is the value they given? So this is the third one, so this is the value 91. Okay, plus for HCl how much the middle one? So this is a value 425.9. Okay, now NaCl how much they given? NaCl they given 126.4. Yes, so from this you can calculate the value. So by doing this you will be getting 96516 minus 126.4. So from this we will be getting around this 390.5. Okay, so this is our answer, so which is option number A. I hope it is clear, there is no confusion in this discussion also. Okay, so whenever you have any difficulties in understanding any of these questions, write in the comment box. We can discuss about that in the upcoming sessions or in the comment box itself. Okay, so do not bother about any difficulties, just make everything clear while learning the things. Okay, now let us discuss one more question from electrochemistry here. So here what they are saying, how much charge is required for reduction of 1 mole of manganate to permanganate here, MnO4 minus to Mn plus 2. So here manganate, permanganate ion is having plus 7 charge. So here permanganate is having Mn plus 7 is the oxidation state. Okay. Now this to be converted into Mn plus 2. So it means Mn plus 2. So for this, see, plus 7 is reduced to plus 2. So this is what the question they are asking. So for this conversion, how much charge is required? Okay. So for 1 mole of this conversion, how much charge is required, they are saying. Okay. So for decreasing this number from 7 to 2, we required 5 mole of electrons. Okay. For each mole of manganese plus 7 to plus 2 conversion, we required 5 mole of electrons. Okay. Sorry, 5 mole of electrons. Okay. So each negative charge decreases this charge plus 7 by 1 unit. Okay. Therefore, to decrease 5 units, we require 5 moles of electrons for 1 mole of this Mn plus 7. I hope it is clear. So now how can we say this? So for 1 mole we require this. So this is what 5 Faraday is required. So how can we giving this directly answer means you can just remember like this. So for 1 GN of any substance, so in order to deposit 1 gram equivalent of any substance, we required 1 Faraday. Okay. So now gram equivalent number, how can I write? N into N factor I can write. Okay. So now how much N into N factor means how many moles they mentioned? 1 mole. So how many Faradays we require? What is the N factor? Plus 7 is converting to plus 2 means factor is by 2. Factor is 5. So therefore total gram equivalent number is how much? 5, right? So for 1 Faraday, 1 gram equivalent, 1 Faraday required. For 5 gram equivalents, 5 Faradays are required. So what is the correct one here? Option B is correct. 5 Faradays are required here. I hope it is clear. No confusion in this, right? So let's move further. Question number 8. The product formed at cathode and anode by electrolysis of aqueous NaCl solution respectively. So this is aqueous, na? So aqueous means what are the cations and what are the anions we have in that electrolysis solution. So aqueous means we have water along with this NaCl. Okay. So from this we can have Na plus ion, Cl minus ion, and from here we have H plus ion, and from here OH minus ion from water. Okay. Now depending upon their reactivity, so according to the preferential discharge theory. So which species will discharge at cathode? See, these cations undergoes reduction. Okay. Out of these two, only one cation will undergo reduction. This is at cathode. Okay. So cations move towards cathode, which is having negative charge, and anions move towards anode, which is having positive charge. Okay. So now, so these anions attracted towards anode, which is having positive. Cations attracted towards cathode, which is having negative charge. Okay. I hope it is clear. So now out of these two, so H plus, see, we know alkali metals are electropositive, so therefore they will be stays in plus 1 oxidation state only. So therefore hydrogen will be easily discharged first and gives H2 gas. And here based on the preferential discharge theory, so out of this Cl2 gas is liberated at anode and H2 gas is liberated at cathode. So option number 2 is correct for this question. Okay. Option number C is correct for this question. Okay. So the next. The artificial sweetener used only for cold food is. So for cold food, see, aspartame is the best choice now. Why? Because aspartame will be a sweetener first and it will be unstable at high temperature. At cooking temperature it is unstable. Okay. Therefore it is only preferred in the cold foods only. So aspartame is the correct. So you can go with option number C. Okay. Let's move further. Okay. The rate constant K is given, the order of the reaction is. So it means by looking at the rate constant, we need to find its order. Okay, we need to find its order. So how can we derive this? See, I will be giving you one general like equation in order to derive the units of this rate constant for different orders. Okay. So now here what we have, liter, mole inverse, second inverse. This is what the units we have now. So now based on this we will need to do here. See, so just take units of K. This is a generalized formula, you can remember. Concentration power 1 minus n time inverse. This is the formula you can use. Okay, so concentration you can also write mole per liter 1 minus n time inverse. So time will be considered to be in the second inverse only, so no issues to discuss about seconds, so no issue with this seconds. So now here by placing n value we can get a satisfied version of this units. Okay, so by placing 1 we will get, if n value is 1, then 1 minus 1 0, therefore this is no units. So for first order the units for rate constant will be second inverse only. So for in order to get this, what is a suitable n value? So if the suitable n value is n, if n is n is 2, so if n value is 2, so what we are getting, just check. So mole per liter 1 minus 2 second inverse. So 1 minus 2 means minus 1 na? So mole power minus 1. Here already liter in the denominator having minus 1, if I write in the numerator, again minus 1 into minus 1 plus 1. So mole inverse liter second inverse. So this is what the unit we got. So n value is how much in this case? It is 2, therefore order is 2. So here n represents order of the reaction. Okay, order of the reaction. So what is the order? Second order reaction. So option C is correct for this question. Right now it is clear, right? Next, decomposition of ammonia on platinum surface is zero order reaction if K is given like this. What is the rate of production of H2? So how can I write? So rate of a reaction. So rate equation can be written as rate equation. So we can write K into concentration of reactant to the power their order. Okay, since order is 0, so I am writing K into reactant concentration to the power 0. So something power 0 will be 1, so I am writing K naught into 1. So this is what I have mentioned here. So rate I can write. So rate means change in concentration with time. So dx by dt I am writing. Okay, up to here it is clear now. So now one more thing we can do here is, so what they are asking, ammonia decomposition. So what is the equation for ammonia decomposition? A balanced equation should be written here. So N2 plus H2. So balance these. So here you can take 1, here you can take 3. Therefore this will be balanced now. So now to this we need to write rate equation. So rate expression for this is given equals to dx by dt, which represents rate of change in concentration with the time. Okay, so now what I can write here? So for reactants, write the concentration of reactant here, dNH3 by dt. So what is its coefficient? 2 now. So write here 1 by 2 and place negative symbol here, because this is what the reactant converting into this form. That is what the decomposition of ammonia. So what is forming here? So it is plus 1 dN2 by dt. Okay, 1 by 1 means 1 only, that's why I am writing like that. Okay, for H2 what is the coefficient here? We have 3 and this is forming now. So 1 by 3 dH2 by dt. So this is how you need to write. Okay, so what is the rate of production of H2 they are saying? So what is the rate they have given here? So rate constant, how much they have given here? See, rate equals to K naught. So I am directly taking that value. So 2.5 into 10 power minus 4, which is equals to rate of production of H2. So this is the value they are asking. So if I send this value to that, I mean this into 3 will be giving this dH2 by dt. That's it. So we got our answer, that is 7.5 into 10 power minus 4. So this is our answer. So we have option number 2 in that form, right? So that is our answer for this question. Now I will be giving you one more question, because this is very frequently asked question. Now I will be asking same question, same data, the rate of, write the answer for this question. The rate of production production of N2, rate of production of N2. So what is the value for this? You can write in the comment box, and also the decomposition. So now in one more question here I am giving the rate of deformation of ammonia is how much? So these are the two questions. You can take them as homework and write in the comment box. Okay, so question number *1, *2 you can write in the comment box for these particular questions. Okay, let us discuss few more things from chemical kinetics. So here we have question number 12, molecularity of the following elementary reaction. Okay, so they are mentioned it as elementary reaction. Always remember, for elementary reactions, see whatever the coefficient mentioned here in front of that reactant, that will be their order. Okay, for elementary reaction, let us say I am writing here A plus B 2B giving rise to some C. If I am saying this as an elementary reaction, whatever the coefficients they mentioned here, that will be their orders in the reaction. So what is the order of A? 1. What is the order with respect to B? It is 2. What is the total order? It is 3. So like this you need to answer during the solving the questions. Okay, now here molecularity. So molecularity means in the rate determining step how many reactant molecules are involved. So that is given by number of reactant molecules only here. Okay, so for this only one molecule is involved, so therefore this only one reactant is present in the reaction in the molecularity, therefore I can say what is the molecularity? 1. So option number 2 is correct, B, option B is correct. Okay, 1 is here. Okay, let's move further. Which of the following is not the characteristics of physisorption? See, I told you in the last session also. So I think for CUET, surface chemistry is one of the very important topic here. Okay, so there you can focus on what are the basic terminology like adsorbent, absorbate, these things, absorption, desorption, adsorption, absorption, these terms you need to know. After that, the physical process like physisorption, this process like physisorption and chemisorption. So these are the two things you need to know. Okay, after this, so you need to understand what is Langmuir absorption isotherm and also Freundlich absorption isotherm. These are the things you need to focus from this chapter. Okay, so what about physisorption here? So this is a physical process I can say. Okay, so it arises because of van der Waals forces. Yes, so this type of absorption or absorption takes place, this type of process takes place because of van der Waals forces. Okay, so next, it is not specific in nature. Yes, physisorption is not specific in nature, whereas chemisorption is specific in nature. Okay, and then next, for physisorption, what they are asking here, which are the following is not the characteristic property, right? Okay, this is the this is correct only, not they are asking. No? So enthalpy of adsorption is high. So for physisorption, the enthalpy of absorption is low actually. Okay, that is not high, this is low for physisorption, whereas for chemisorption it will be high. Okay, so this is the wrong statement they have mentioned here. So they have mentioned this is the wrong statement. So this is what you need to choose because not the characteristic of physisorption. So you can go with option number C. Okay, it results into multi-layer on the absorption of surface under high. Yes, since it is a physical phenomena, so yeah, so it results to multi-layer process. Okay, multi-layer on the adsorbent. Okay, and for chemisorption it will be monolayer. Okay, unilayer we can say. Okay, so option number is C is correct for this particular question. That is what you need to choose. It means this is not a valid statement. That is what you need to choose here. Which one of the following is an emulsion? So emulsions means what? So colloidal solutions formed by mixture of two liquids, right? Two liquids. So that is which one? So smoke means that is solid plus gas. Okay, so here the best option is hair cream, so which is made up of two liquid substances only. So you can go with option number 2 here. Option B is the correct. Okay, again solid means liquid plus solid, na? Paint means liquid plus solid, na? Again cheese also means what? some creamy substance like gel forms plus liquid, right? So which is the best suitable answer? Hair cream is the emulsion here. Caprolactam is a starting material of what? So caprolactam is a monomer of nylon 6. So what is that? Nylon 6. Whereas what about nylon 6,6? It is adipic acid plus hexamethylene diamine. Okay, so nylon 6,6 is a polymer made up of adipic acid plus hexamethylene diamine, whereas nylon 6 is formed from caprolactam. Okay, caprolactam polymer is what? Nylon 6. Nylon 6,6, see here 6 is 2 are there now, so you can remember like that. One is adipic acid plus hexamethylene diamine is giving this nylon 6,6, whereas nylon 6 is formed from just caprolactam. That is what you can remember. And just to avoid confusion, I have told you that whenever you are seeing 2,6 nylon 6,6, so that case you can remember there are 2 reactants, 2 monomeric units, like 2 different monomeric units which are combining to form this compound, whereas nylon 6 is only 1 6 is there, only one monomeric unit which is combining with itself to form the polymer. Okay, next, which of the following is a positively charged colloid? Okay, so which one is that? So blood is a positively charged colloid now. Okay, so we are also see every time we will be seeing one question definitely on this negatively charged solutions, positively charged solutions, and the next adsorption, physisorption, chemisorption, these things, right? So you should not skip the questions chapter of this surface chemistry at any cost. Okay, focus on that. So option D is correct for this question. Next, for 17th question here, CD right, again from metallurgy. I hope I have seen this, I think second or third time. So same kind of minerals are giving, some minerals are giving their names, are asking, the formulas are giving their names, are asking like that. So otherwise for which metal which is a suitable mineral we can opt for, that is what they are giving now. So you should not skip this basic thing also, just because these things are very time saving things. So nothing to solve, just looking at the question, and if we know the answer, particular answer for that question, so we can directly choose. So for CD right, it is for iron, right? So for CD right, iron. So A2, so A2 where do we have? See here we have A2 is only option in B, there is no other option. So by using elimination method also we can directly take option number 2 without any wastage of time. Okay, this is our correct option, so this B. Okay, because CD right is for iron, which is here A2. The next malachite, malachite is for copper. Okay, so calamine is for zinc. Okay, and the next bauxite for aluminum. That's it. Very basic things now. Okay, important. You should at least focus on the repeated questions, at least minerals and their formulas, and the metal, especially what metal it is given in that mineral. So that is what you should focus here. The metal refined by Van Arkel process. What is a metal? Which metal is refined by Van Arkel process? One is titanium, another one is zirconium. So in this titanium is not mentioned, zirconium is mentioned here. You can go with option number B. Okay, so just look into the what are the metal refining methods we have in the metallurgy. That is also important topic from metallurgy. Okay, next, stability of thermal stability of hydrates. 16th group hydrates are given and their thermal stability is asking. So this is also standard question only now. So I have observed that in CUET, so they will be focusing on very standard topics. Okay, so this will be like a good thing for you, because even if you like study that important topics, like see, we know like thermal stability, reactivity, reducing nature, and down the group acidic nature of the 16th group elements, we will be generally we will be studying for, even if it is for boards we will be studying now. So that is how the paper is setting here. So you can follow that basic like concept at least at this last minute if you are preparing for this 2025 exam itself. Okay, so for 2026 you can go very deeply, but for the next upcoming exam you can just look at the very important topics. Okay, now tell me, water like H2O is there, H2AC, so group 16 hydrates here we have. So what happens? So due to the size difference, so down the group what happens to the size? So size increases and orbital overlapping will becomes weaker. So H2S, H2O will be having like hydrogen, oxygen having almost similar size, similar sizes means comparable sizes. Like here 1s orbital, here it is 2s. Whereas for sulfur and hydrogen, it is this is 2p, this is 3p, here it is 2p, and this is 1s in all the cases for hydrogen, and this is 3p in the sulfur case, and for oxygen, sulfur, selenium, so this is 4p. So like this, see the orbital size is increasing now, so overlapping becomes weaker, therefore down the group due to the size difference their overlapping is very poor, therefore a bond easily breaks, so the stability decreases down the group. So which is more stable? I can say H2O is more stable, the next H2S, the next H2S, so H2Se. So this is how you can arrange them. So based on this, H2O is first one, so A is here and here, and H2S is E, so here only we have, so the next selenium hydride, yes, so option number B is correct. That's how you can choose it. Hope it is clear. Next let us move further. Ammonia. So ammonia, how it is prepared? Ammonia is prepared from Haber's process now. So again this process are also asking. So in the last paper also we have seen nitric acid, right? Next sulfuric acid we have seen. So in like standard preparation methods are also focused. Okay, so ammonia by Haber's process. What is the catalyst used? So iron catalyst, right? So A4 in all the options, we can't give the answer directly. So nitric acid by Ostwald process. So D1 is there only in the first option, so you can directly go with the option number 1. Okay, and sulfuric acid by contact process C2, D1 C2, chlorine by Decon's process B3. That's it. So we got option number 1 is the perfect answer for this question. The formula of noble gas species, the formula of a noble gas species which is isoelectronic with BrO3 minus. See here we have BrO3 minus. So what is the formula, what is the structure of this BrO3? Let us find. So bromine belongs to 17th group now. So how many valency electrons are there? 7. What is the charge here? We have negative charge is 1. So add plus 1. So by 2 you can do. So 8 by 2. So which means 4. So hybridization 4 means we can say 1 s orbital, 3p, sp3 hybrid orbitals are there. Okay, BrO3 minus. So how many surrounding atoms are there? 3. So out of these 4, 3 are bond pairs, and 1 is lone pair. Okay, 1 is lone pair. So from this I can write bromine in the middle. Okay, here I am setting 1 pair of lone pairs, lone pair electrons here in this, and here I am writing like this. So what is the shape of this molecule? So this is pyramidal. In tetrahedral, if one of the atom is removed out of 4, so the remaining atoms will be having a tetrahedral geometry, having pyramidal shape. What is the shape? Pyramidal shape. So this will be pyramidal. Like this, in the given 4 options, which will be having pyramidal. So directly you can choose this. Why? Because xenon group number is 18, so valence electrons are 8, monovalent atoms are not there, so oxygens only there, so we cannot take oxygens into the count, so divalent atoms into this formula, in this trick formula, so you can directly take. So 4, similarly 4 we got. How many surrounding atoms are there here? Xe, O3 are there, na? So out of 4, 3 are bond pairs, 1 is a lone pair, so which gives pyramidal geometry, right? So I hope it is clear why option C is correct here. Okay, now for this we have see, if you are not aware of this topic like valency shell electron pair repulsion theory, I have made a special video on valency electron pair repulsion theory, very exclusively on this kind of questions, so you can go through that. That will be useful for all your exams like JEE, NEET, EAP set, CUET or BITSAT, any exam there will be a question on this topic, so you can watch it. Along with that you can also watch MOT. These 2 topics you can go through the playlist. Next question here we have maximum oxidation state for these elements. Okay, so let us start with this manganese. So manganese valence electrons atomic number is 25. If atomic number is 25, so you can write 3d5 4s2. So how many valence electrons are there? 7, right? So all the 7 electrons can be removed. So therefore it will be getting Mn plus 7. Mn plus 7. So this is the oxidation state. So you can say C1. So C1, where do we have C1? So we have it only in the first option. You can directly choose the option number 1. Okay. So in CUET I have observed that elimination method is working more in case of match the following. So just by looking 1 or 2 option also you are going to eliminate the options. I mean you can easily eliminate the options. Okay. So for titanium, scandium, titanium na, so it means 22. So 22 means 3d2 4s2. So now we can remove all these 4 electrons and can show plus 4 oxidation state. A4, A2, 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 that's it. So remaining you can verify. So only option 1 will be the perfect answer for this question. Next 23, the metal from first transition state is having positive reduction potential value. So M plus 2 to M. It means what is this process? It is reduction. What is this? It is reduction. So it is reduction. If this is a reduction process, now look. So all these metals, chromium, vanadium and nickel will be having negative values, but they are asking which will be having positive reduction value. That is only for copper. That value is like copper plus 2 to copper. So this will be plus 0.34 volts, right? So this is the only one metal which is having positive out of these 4 options. So you can choose option C. Okay. Then next we have, so which the magnetic moment of a divalent ion in the aqueous solution of element with atomic number 25. See, easy, right? So atomic number 25 means what is that? Atomic number 25 means manganese. Okay. So what is its electronic configuration? 3d5 4s2. So they are saying divalent na. So divalent means manganese plus 2. So if it is in plus 2, remove 2 electrons out of this 7. So 3d5 4s0. Now we have 5 unpaired electrons in d orbitals. 1, 2, 3, 4, 5. 5 unpaired electrons. So now if unpaired electrons are 5, so what is the magnetic moment formula? Spin only magnetic moment, mu equals to root over n into n plus 2 Bohr magneton. This is the formula you can use. Mu equals to root over n value is 5. So 5 into 5 plus 2, 7 Bohr magnetons. Okay. So now look here, mu we got around 35, root 35. So we know root 36 is 6 here, which is nearly equals to 36 but not 36. It is little lesser than 36. So I can say mu value will be nearly equals to 6, that is 5.92, which is there in the option number D. That is our correct answer for this question. I hope it is clear now. Next. Okay. So with this question we will be winding up the session. So the remaining questions we will be discussing in the next session of this CUET question paper discussion. Okay. What is the 25th question? Which are the following transition metal ion is colorless? Yes. So these transition metals will show colors due to DD transition. If any of this d orbital contains electron, so excitation, the transition of electron from lower energy d orbital to higher energy d orbital takes place, and this phenomena results to exhibit the color. Okay. So now here in the scandium, look what is the electronic configuration. The scandium atomic number is 21. Atomic number is 21 for scandium. It means 3d1 4s2. Now it is in trivalent like Sc plus 3. So 3 electrons are removed, therefore it will become 3d0 4s0. So no electrons to undergo transition now. So it will not exhibit dd transition because there is no d electrons, right? So it will not exhibit any color. So you can directly choose option 1. Okay, because no color exhibition, no color. Why no color? No dd transition, no dd transition in first option, no dd transition. When it comes to vanadium, scandium, titanium, vanadium, so it means 3d3 23 means 3d3 4s2. Okay, this is the atomic electronic configuration of vanadium. So it is in the +2 oxidation state, means you can say 3d3 4s0. So now we have 3 unpaired electrons in the d orbital of this vanadium +2. So this can undergo electronic transition and can exhibit some color, right? So it means this can show color property. Similarly this one and this one also can show color property because of presence of d orbital electrons. Okay, so dd transition is possible in B, C, D options but not in A, right? Hope it is clear and the session is very useful to you and it is going very well, right? So if you really like the content, please click on the like button, and also you can share with your friends so that we can reach more and we can grow more and we can make things more and more effectively, right? So I hope everything going well. So happy learning. Thanks for watching.